Hello and welcome to another video on ChatGPT prompt engineering for developers. So in this section or in this video, I will walk over to the different concepts and topics on this course. So first on the introduction, Andrew and G mentioned that yes, on the internet you might find articles like 30 prompts everybody has to know. And this is more oriented to the ChatGPT web interface, where a lot of people often use for one-off tasks. But the power of this large language model lies in, for developers, is to building applications quickly using the LLM APIs, especially OpenAI. Now, this is something that Andrew MG, and the reason why he created a sister company from deep learning called AI Fund to see what are the startups or products that they can create that can use these LLM APIs. So in the development of LLMs, we have broadly two types of large language model. So base LLMs, which are focused on predict the next word using training data that can come from different sources, even the internet. And when you prompt things like once upon a time there was a unicorn, the model will likely to complete that with that live in a magical forest with all her unicorn friends, right? But when you prompt now, what is the capital of Paris? I mean, what is the capital of France? The model will likely to complete with what is the French population? What is the French largest city? What is the currency of France? Because articles on the internet that this LLM use to be trained have or are likely to have this list of quiz about the country of France. So in contrast, the instruction to an LLM that attempts to follow instructions. So when you prompt things like, what is the capital of France? It will likely to complete with the capital of France is Paris. Okay, so great, because the way how this works, you start with a base LLM, you train with a huge amount of data, and then you further train it to tune in that accept inputs and outputs that attempts to follow instructions using refined techniques like reinforcement learning with human interact or with human feedback. And this is to make the model much more helpful, and because the model or the people behind the scenes train this model using that, so these models are honest, helpful, and harmless. So this kind of models are less likely to have problematic or toxic output. So you can think of this LLM, after all, as a person who's smart but doesn't know the detail, and providing context will help them to perform the task. So Andrew NG used an example like when you ask someone about, or in this case, an LLM about Alan Turing, so it is helpful to provide is the context. Okay, so what do you want to know about him? So his personal life, his scientific works, mm, his role in history, or something else. And also, it's important to indicate the tonality of that. Meaning is like how do you like this outcome or this output in a professional journalist or something more casual? So first I look at the guidelines, okay? Using Jupyter notebooks to see easily how can we interact with the prompt. And the guidelines are right, or the principles here, the two principles is write effective instructions as well as a couple tactics such as delimit or use delimiters to clearly define different part of your inputs. Delimiters like triple backticks, triple quotes, triple dashes, angle brackets, XML tags. Also ask for structured data such as JSON or HTML, and check whether the conditions are met or the assumptions, as well as give few shotting or do the few shotting, meaning provide successful examples to the model and then or provide successful examples to perform a task and then let the model perform the task. And the second principle is give the model time to think, much like a person, where you ask someone to give you an answer based on a complex math question. So if you don't give them time to think about the questions, it's likely that they give you it's likely that they will give you a wrong answer. So much like here on this model, so when you receive an incorrect conclusion, so what you can do is to define several steps or to reframe that uh, prompt with a series or a change of tasks to do. So the first tactic is give the model step to complete the task, all right? And the other is instruct the model to work out its solutions before rushing to a conclusion. So an example of this is you have an study solution for a math problem and the math problem, so you instruct your model, hey, please figuring out what is the solution of this, all right? And then compare the solution from the student to see if that is right or wrong. Then I look at the iterative process, especially when you want to systematically engineering uh, writing good prompting, right? So following is the uh, machine learning workflow, which is the idea, and then from the idea you implement is the data and the the code. You get the result from that, these experimental results, and then you perform some error analysis to get to iterate that again until you get the final outcome or the outcome that you want, right? So this is somewhat similar to the prompting developing for the prompting developing applications, where now Isa Fulford, this structure from OpenAI, mentioned that it is important, it is more important to have a good process for, it is important to have a good process that works toward a good prompting until you get something and then iterate that. So the whole point of this is it is important to have a good iterate. It is important to have a good iteratively. Yeah, it is important to have a good iteratively, which is something that she mentioned here. It is important to have a good iterative. Okay, so as long as you have a good iterative, as long as you have a good process, so as long as you have a good process to iteratively, iteratively, exactly. So as long as you have a good process to iteratively make your prompt better, you're able to come, you'll be able to come out with something that works well for your task. So after all, this is that sentence, as well as long. So as long as you have a good process to iteratively make your prompt better, you'll be able to come out with something that works well for your task. But that's the crucial aspect here, especially when you are in this iteration, or define again, TLDR. As long as you have a good, as long as you have a good process to iteratively make your prompt better, you will come with something that will work, or you come up with something that works well for your task. Okay, so in our case, it can be from the idea. So you write clear instructions, okay, and then you get the results. You analyze why you don't get a desired output, and then you refine the idea on the prompt and repeat the process. So that's the whole point of this. So you get an idea, you write that on the prompt, you get the results, you analyze why you most of the time you wouldn't get a first uh, uh, you most of the time you wouldn't get at first shot a good yeah, most of the time you wouldn't get at first shot the results that you want, right? If you get it, that's great. But most of the time, uh, you write the prompt, you write a specific instructions, okay? You write specific instruction, you get the result, you figuring out why you're not getting is the desired output, you refine your prompt, or you refine the idea and the prompt and repeat. Okay, so this is the how can we systematically engineering good prompting. And then, well, now looking at the several use cases that we can do uh, with this LLM. So, summarizing here is, after all, one of the most widely common use here, especially when there is a lot of things on the internet of things that we would like to have time to read. So the keyword here is that is summarizing and extract, right? And the use case for this can be, and this is widely used, is for any amount of text or piece of text that an application receive, so people can use, or your application can summarize this kind of text to give people an idea of what is in the text, and then provide a link or a button to optionally dig in if they wish, right? So to optionally dig in if they wish. So this is summarizing. And then I look at inferring. So because inferring is another use case that allowed this tool, or that allowed this small person to do inferring, this LLM API inferring. So Isafol for mentioned that she thinks especially when yeah, she thinks that yeah, she think of any of these tasks: summarizing, inferring, transforming, and expanding. So I think of it. So I like to think of this task where the model takes an text of input and perform some sort of analysis. Okay, so this is a one way that you can look at how is processing that. Okay, or how is doing this task, right? So you can think of this as, or well, you can think of this task as the model takes text of input and then performs some sort of analysis. And this could be summarizing, extracting topics, labels, sentiments, and that kind of things. And then Andrew mentioned, and again, this is talking about is the specific task: summarizing, inferring, transforming, and yeah, transforming and expanding. So Andrew and G now give you a perspective about why, for example, in the traditional programming workflow, you need to collect the label data set, then train the model. Okay, so meaning it's spending computational time, and then deploy your model anywhere on the cloud. And this is just for one single task. Okay, so this workflow works pretty well, but requires a lot of work to do, right? And also for every task, okay, such as sentiment classification, topic extraction, extracting names, that you have to deploy a separate model. But the power of this large language model is that we can perform several tasks pretty quickly, which accelerate, yeah, which give tremendous, which give tremendous speeds in terms of application development. And the other is simplicity, because now we can use this one model, one API to do this different task. Okay, so that's the beauty of this. Okay, this is giving you a little bit of context of how this machine learning, how the machine learning workflow works. Okay, like getting or collect the label data set, then train the model. So spending computational time, okay, so to train it, and then deploy your model. And this workflow is pretty well, but it requires a lot of work through that process. And also, this is, and also for tasks like sentiment, extracting names, among others, for those tasks, you have to deploy a different model. But now with this large language model, okay, we can now use several, or we can write prompts to get several of these tasks quickly, which give tremendous speed in terms of applications development, as well as simplicity, because we have this just one model, one API to do different tasks. Mhm. One model, one API to do different tasks. So rather than figuring out how to train and deploy a model for yourself. So okay, this is about inferring. So all right, now this is all about the theory, and then okay, So let's jump into the practice, which is this.
If I want an example, I start generating results pretty much right away. And that gives tremendous speed in terms of application development. And you can also just use one model, one API to do many different tasks rather than needing to figure out how to train and deploy a lot of different models. And so with that, let's jump into the code to see how you can take advantage of this. So here's a usual starter code. I'll just run that. And the motivating example I'm going
Yeah,
to
usual
use is
start
a
code.
review for a lamp. So needed a nice lamp for my bedroom, and this one had additional storage, and so on. So
Okay, let me read about this lamp review. Need a nice lamp for my bedroom, and this one had additional light storage and not too high of a price point. Got it fast. The string to our lamp broke during the transit of the company, and the company happily sent over a new one. Came within a few days as well. It was easy to put up together. I had a missing part, so I contacted their support, and they very quickly got me the missing piece. Lumina seems to me to be great company that cares about their customers and products. So this is a lamp review.
let me write a prompt to classify the sentiment of this. And if I want the system to tell me, what is the sentiment, I can just write what is the sentiment of the following product review.
Okay, so keywords here. So keywords or topics, uh, prompt, prompts, keyword or topics. Okay, prompt, keyword or topics. I think it's more like topics rather than other things, but it's okay. Prompt, keywords and topics, summarizing an extract. Okay, so the prompts, keyword and topics are sentiment. Oh my god. I definitely not feel good about it. Sentiment.
With the usual delimiter and the review text and so on, and let's run that. And this says the sentiment of the product review is positive,
Exactly.
which is actually
Positive or negative.
seems pretty right. This lamp isn't perfect, but this customer seems pretty happy. Seems to be a great company that cares about the customers and products. I think positive sentiment seems like the right answer. Now, this prints out the entire sentence. The sentiment of the product review is positive. If you wanted to give a more concise response to make it easier for post processing, I can take this prompt and add another instruction to give you answers a single word, either positive or negative. So it just prints out positive like this, which makes it easier for a piece of text to take this output and process it and do something
Mm-hmm.
with it. Let's look at another prompt. Again, still using the lamp review. Here, I have it identify a list of
Identify
emotions that the
type
writer
of
of the following
emotion.
review is expressing. Include no more than 5 items in this list. So, large language models are pretty good at extracting specific things out of a piece of text. In this case, we're expressing the emotions. And this could be useful for understanding how your customers think about a particular product. For a lot of customer support organizations,
Yeah, this is mainly helpful for customer for that, it's like customer. So use case. So I prefer to rename this with numbers here, it's like this, that's right. Identify type of emotion. So for example, for identify customer product reviews.
reviews, it's
as
important
well as
to
other
understand that a
topics that
particular
are
user
more
is
creative and
extremely
are more
upset.
fucked up.
So you might have a different classification problem like this. Is the writer of the following review expressing anger? Because if someone is really angry, it might merit paying extra attention to have a customer review, to have customer support or customer success reach out to figure out what's going on and make things right for the customer. In this case, the customer is not angry. And notice that with supervised learning, if I had wanted to build all of these classifiers, there's no way, I would have been able to do this with supervised learning in the just a few minutes that you saw me do so in this video. I'd encourage you to pause this video and try changing some of these prompts. Maybe ask if the customer is expressing delight or ask if there are any missing.
It's expressing anger, it's expressing joy. Okay, I need to reload all of this. Set up this. Identify type of emotions. Then do this. Okay, it's expressing joy. It's expressing indifference. It's expressing. Okay. The writer of the following reviews expressing. The writer of the following review expressing indifference. Expressing indifference. Empathy. Mm,
Parts and see if you can get a prompt to make different inferences about this lamp review. Let me show some more things that you can do with this system, specifically extracting richer information from a customer review. So,
so extract
information
information.
extraction is the part of NLP, of natural language processing, that relates to taking a piece of text and extracting certain things that you want to know from the text. So in this prompt, I'm asking it, identify the following items. The item purchase
This is
and the name of
extract
the company that made
rich.
it is the parting richer information
Extract richer information.
from a customer review. So information extraction is the part of NLP, of natural language processing, that relates to taking a piece of text and extracting certain things that you want to know from the text. So in this prompt, I'm asking it, identify the following items, the item purchase, and the name of the company that made the item. Again, if you are trying to
Information
summarize
extraction.
many reviews from an online
Identify
shopping e-commerce website, it might be
names.
useful for your large collection of reviews to figure out what were the items, who made the
Naming.
item, figure out positive and negative sentiment, to track trends about positive or negative sentiment for specific items or for specific
Identify
manufacturers. And
company
in this
name.
example, I'm going to ask it to format your response as a JSON object with item and brand as the keys. And so if I do that, it says the item is a lamp, the brand is Luminar, and you can easily load this into the Python dictionary to then do additional processing on this output. In the examples we've gone through, you saw how to write a prompt to recognize the sentiment, figure out if someone is angry, and then also extract the item and the brand. One way to extract all of this information would be to use 3 or 4 prompts and call get completion, 3 times or 4 times, extract these different fields one at a time. But it turns out you can actually write a single prompt to extract all of this information at the same time. So I'm going to say identify the following items, extract sentiment, is reviewer expressing anger, item purchase, company that made it, and then here I'm also going to tell it to
He's a
format
Venezuelan
the anger
rapper and
value
singer
as
who
a,
was
as a
known for
Boolean value.
his dark
And then we
and
run
aggressive
that.
style of music. He passed away in
And this outputs
2015.
a JSON where sentiment is positive, anger, and then no quotes around false because it also it's just outputted as a Boolean value. It extracted the item as lamp with additional storage instead of lamp. Seems okay, but this way you can extract multiple fields out of a piece of text with just a single prompt. And as usual, please feel free to pause the video and play with different variations on this yourself. Or maybe even try typing in a totally different review to see if it can still extract these things accurately. Now, one of the cool applications I've seen of large language models is inferring topics. Given a long piece of text, you know, what is this piece of text about? What are the topics?
And doing
Here's
multiple
a
tasks as
fictitious
one.
newspaper article about how government workers feel about the agency they work for. So the recent survey conducted by government, and so on.
Doing
Results
multiple
reviewed at NASA was a
tasks
popular department with high satisfaction rating.
as
I
one.
am a fan of NASA, love the work they do, but this is a fictitious article.
Sentiment
And so, given an article like this, we can ask it
classification.
with this prompt, determine
Exactly.
five
Sentiment
topics that are being
classification.
discussed in the following text. Let's make each item 1 or 2 words
Sentiment
long, format your response in
classification.
a comma separated list. And so if we run that,
Doing
we
multiple
get
tasks one.
this article is about a government survey, it's about job
Sentiment
satisfaction, it's about NASA,
classification.
and so on. So overall, I think pretty nice extraction
And
of a list of
topic
topics. And of course, you can
extraction.
also, you know, split it so you get a Python list with
Information
the 5
extraction or
topics
topic
that this
extraction.
article was about. And if you have a
Inferring
collection of
topics.
articles and extract topics, you can then also use a large language model to help you index into different topics. So let me use a slightly
Inferring
different topic list. Let's
topics.
say that we're a news website or something, and these are the topics we track: NASA, local government, engineering, employee satisfaction, federal government. And let's say you want to figure out, given a news article, which
Counter
of
the
these
number.
topics are covered in that news article. So here's a prompt that I can use. I'm going to say, determine whether each item in the following list of topics is a topic in the text below. Give your answer as a list of 0, 1 for each topic.
Counter
And so,
number.
great. So this is the same
Counter
story text
number
as
of.
before. So this thing's a story. It is about NASA. It's not about local government. It's not about engineering.
Use
It
case
is
for
about employee
identify
satisfaction, and it
customer
is
product
about
review. Counter
federal
number.
government. So with
Yeah,
this,
counter
in
number.
machine learning, this is sometimes called a zero-shot learning algorithm because we didn't
Counter
give it any
number of.
training data that was labeled. So that's
Counter
a zero
number.
shot. And with just a
Counter
prompt, it was able to determine
number
which
of
of these topics are
topics.
covered in that news article.
Like
And
extract topic.
so if you want to generate a news alert, say,
Extract
so that
topic
process news and
and
I really
count
like a lot of the work that NASA does. So
topics
if you want to
on a
build
text.
a system that can take this, put this information
Mhm.
into a dictionary, and whenever NASA news
Infer
pops up,
5
print
topics.
alert, new NASA story, they can use this to very quickly take any article, figure out what topics it is about, and if the topic includes NASA, have it print out alert, new NASA story. Oh, just one thing. I use this topic dictionary down here. This prompt that I use up here isn't very robust. If I wanted a production system, I would
They can use
probably
the left
have
for
it
certain topics.
output the answer as in JSON format rather than as a list because the output of the large language model can be a little bit inconsistent. So this is actually a pretty brittle piece of code. But if you want, when you're done watching this video, feel free to see if you can figure out how to modify this prompt to have it output JSON instead of a list like this, and then have a more robust way to tell if a particular article is a story about NASA. So that's it for inferring. And in just a few minutes, you can build multiple systems for making inferences about text that previously this would have taken days or even weeks for a skilled machine learning developer. And so I find this very exciting that both for skilled machine learning developers as well as for people that are newer to machine learning, you can use it for inferring. And in just a few minutes, you can build multiple systems for making inferences about text that previously this would have taken days or even weeks for a skilled machine learning developer. And so I find this very exciting that both for skilled machine learning developers as well as for people that are newer to machine learning, you can now use prompting to very quickly build and start making inferences on pretty complicated natural language processing tasks like these. In the next video, we'll continue to talk about exciting things you could do with large language models, and we'll go on to transforming. How can you take one piece of text and transform it into a different piece of text, such as translate it to a different language? Let's go on to the next video.
Okay, let's go on to the next video. Transforming.
Large language models are very good at transforming its input to a different format, such as inputting a piece of text in one language and transforming it or translating it to a different language, or helping with spelling and grammar correction. So taking as input a piece of text that may not be fully grammatical and helping you to fix that up a bit, or even transforming formats, such as inputting HTML and outputting JSON. So there's a bunch of applications that I used to write somewhat painfully with a bunch of regular expressions that would definitely be much more simply implemented now with a large language model and a few prompts.
Exactly.
Yeah, I
Instead
use
of implementing.
ChatGPT to proofread pretty much everything I write these days, so I'm excited to show you some more examples in the notebook now. So first we'll import OpenAI and also use the same getCompletion helper function that we've been using
Language
throughout the
translation,
videos.
spelling, and grammar
And the
checking,
first thing
tone
we'll do is a
adjustment,
translation
and
task.
format
So large language models are trained
conversion.
on a lot of text from kind of many sources, a lot of which is the internet, and this is kind of course, in many different languages. So this kind of imbues the model with the ability to do translation. And these models know kind of hundreds of languages to varying degrees of proficiency. And so we'll go through some examples of how to use this capability. So let's start off with something simple. So in this first example, the prompt is, translate the following English text to Spanish. Hi, I would like to order a blender. And the response is, hola, me gustaría ordenar una licuadora. And I'm very...
Jesus! It's because you know what is fucked up of all of this is that because a lot of people on English they're barely they this is something that also that happened on Spanish people. Okay, is that we try forcefully to talk that another language with our native one, okay, with our mother language. But it's, no, they have their own particular way of talking and expressing diagram, dialects, phonetics, fonética en español, phonetics, fonética. So you have is that okay, you have to try to mimic and understand why they talk like that, so you can then communicate in a more efficient and effective way. Okay, so yeah, and not also and also add that you need to also talk about complex ideas in that regard. So it's not only to keep things simple, so only talk about what is the weather, how, for example, what time is it, or casual conversation. Is also more about talk about complex topics. You know, okay, things started to get very, very, very interesting, and we can use translations. For example, you say, ChatGPT, hey, transform all of this text that we have from a particular website, and then catch that so you can let it on serve.
Very sorry to all of you Spanish speakers. I never learned Spanish. Hola, me gustaría ordenar una licuadora. And I'm very sorry to all of you Spanish speakers. I never learned Spanish, unfortunately. as you can definitely tell. Okay, let's try another example. So, in this example, the prompt is, tell me what language this is. And then this is in French. Combien coûte le lampadaire? And so let's run this.
Combien coûte le lampadaire? This is French.
And the model has identified that this is French.
Combien coûte le lampadaire? The fuck is that? Combien coûte le lampadaire? Combien coûte le lampadaire? Combien coûte le lampadaire? What the hell is that? Translate this into... No, what is this? Tell me which language is this? What is this? Translate the following French text to English. Of course, I didn't set up the... Okay, now I did the setup here. How much does the Streamline cost? Combien coûte le lampadaire? Combien coûte? Combien coûte les lampadaires? Combien coûte le lampadaire? Oh my god. Okay. Combien coûte? Jesus fucking Christ. Alright. This is French.
The model can also do multiple translations at once. So in this example, let's say, translate the following text to French and Spanish. And you know what, let's add an English pirate. And the text is, I want to order a basketball.
Well, they want to order a basketball.
So here we have French, Spanish, and English pirate.
An English pirate.
Spanish.
I be wanting to order a basketball. I be wanting to order a basketball. I be wanting. Okay.
An English pirate. So in some languages, the translation can change depending on the speaker's relationship to the listener. And you can also explain this to the language model, and so it will be able to kind of translate accordingly. So in this example, we say, translate the following text to Spanish in both the formal and informal forms. Would you like to order a pillow? And also notice here, we're using a different delimiter than these
Would you like to order a
backticks.
pillow?
It doesn't really matter, as long as it's kind of a clear
¿Te
separation.
gustaría ordenar una almohada?
So here we have the formal and informal.
¿Te gustaría ordenar una almohada? What? That's right, informal.
So formal is when you're speaking to someone who's maybe senior to you, or you're in a professional situation. That's when you use the formal tone. And then informal is when you're speaking to maybe a group of friends. I don't actually speak Spanish, but my dad does, and he says that this is correct.
Your dad knows Spanish. Oh my god.
So for the next example, we're going to pretend that we're in charge of a multinational e-commerce company.
Exactly.
And so the user messages are going to be in all different languages. And so users are going to be telling us about their IT issues in
you with
wide
IT
variety
issues
of
in all their
languages.
native language.
So we need a universal
from all
translator.
the world.
So first
speak
we'll just
all their
paste in
native
a
language.
list of user
a
messages
universal
in a
translator.
variety of different languages.
Exactly.
And
La profonde du système est plus lente que d'habitude. La profonde du système est plus lente que la profonde du système est plus lente que d'habitude.
And now we
Mi monitor tiene píxeles que no se iluminan. What? This is different. Il mio mouse no funciona. Il mio mouse no funciona. Ah, but this, okay.
will loop through
You talk
each
about
of
this?
these user messages. So for issue in user messages,
For issues in user message, you
and
can
then I'm going to
iterate to
copy
each one of
over a
them
slightly longer code block.
and then tell to the prompt, hey, tell me what language is this?
And so the first
Okay, tell me what language is this? And then translate the following text to English and
thing we'll
Korean.
do is ask the model to tell us what language the issue is in. So here's the prompt. Then we'll print out the original message's language and the issue. And then we'll ask the model to translate it into English and Korean. So let's run this. So the original message in French. So we have a variety of languages, and then the model translates them into English and then Korean. And you can kind of see here, so the model says, this is French. So that's because the response from this prompt is going to be, this is French. You could try editing this prompt to say something like, tell me what language this is, respond with only one word, or don't use a sentence, that kind of thing, if you wanted this to just be one word. Or you could ask for it in a JSON format or something like that, which would probably encourage it to not use a whole sentence. And so, amazing, you've just built a universal translator. And also feel free to pause the video and add kind of any other languages you want to try here, maybe languages you speak yourself, and see how the model does. So the next thing we're going to dive into is tone transformation. Writing can vary based on an intended audience. You know, the way that I would write an email to a colleague or a professor is obviously going to be quite different to the way I text my younger brother. And so ChatGPT can actually also help produce different tones. So let's look at some examples. So in this first example, the prompt is, translate the following from slang to a business letter. Dude, this is Joe. Check out this spec on the standing lamp. So let's execute this.
Translate the following from slang to a business letter. Dude, this is Joe. Check out the spec on this standing lamp. Dear Sir Madam, I'm writing to bring you... Oh my god, no. Dear Sir Madam, I'm writing to bring to you attention and standing lamp that I believe may be of interest to you. Please find attached the specification for your review. Thanks for your time and consideration.
As you can see, we have
Joe.
a much more formal business
Hey,
letter
dude, this is Joe.
with a
Check out the
proposal
spec
for a
on
standing lamp
this is standing
specification.
lamp.
The next thing that we're going to do is
Tone
to convert between different
transformation.
formats. ChatGPT is very good at translating between different formats, such as JSON to HTML, XML, all kinds of things, Markdown. And so in the prompt, we'll describe both the input and the output formats. So here is an example. So we have this JSON that contains a list of restaurant employees with their names and email. And then in the prompt, we're going to ask the model to translate this from JSON to HTML. So the prompt is, translate the following Python dictionary from JSON to an HTML table with column headers and titles. And then we'll get the response from the model and print it. So here we have some HTML displaying all of the employee names and emails. And so now let's see if we can actually view this HTML. So we're going to use this display function from this Python library. Display HTML
response in lowercase, that's right.
And here you can see that this is a properly formatted HTML table. The next transformation task we're going to do is spell check and grammar checking. And this is a really kind of popular use for ChatGPT. I highly recommend doing this. I do this all the time. And it's especially useful when you're working in a non-native language. And so here are some examples of
Especially if
some common
if you're
grammar
working
and
in a
spelling
non-native
problems
language.
and how the language model can help address these. So I'm going to paste in a list of sentences that have some grammatical or spelling errors. And then we're going to...
With spelling error, okay, the girl with a black and white puppy have a ball. Yolanda has her notebook. Okay, but the girl with the black and white puppies have a ball. Okay.
loop through each of these sentences.
It is going to be a long day. The girl with the black and white puppies have a ball. It's going to be a long day. There goes my freedom. They're going to bring their suitcases.
And
Read and correct the following text and write
ask the
correct
model to
version.
proofread these. Proofread and correct. And then we'll use some errors. We could use some of the techniques that we've discussed before.
The girl with black and puppy hair. There are no errors in this sentence. Exactly. It is going to be a long day. Does the car need its oil? Anger. This phrase is to check ChatGPT for spelling ability. Spelling ability.
So we could, to improve the prompt, we could say proofread and correct the following text. And rewrite. Oh. And rewrite the whole, and rewrite it, correct it.
Rewrite the correct version. If you
If you don't find any errors, just say no errors found. Let's try this. So this way we were able to, oh, they're still using quotes here. But you could imagine you'd be able to find a way with a little bit of iterative prompt development to kind of find a prompt that works more reliably every single time.
There you go.
And so now we'll do another example. It's always useful to check your text before you post it in a public forum. And so we'll go through an example of checking a review. And so here is a review about a stuffed panda. And so we're going to ask the model to proofread and correct the review. Great, so we have this corrected version. And one cool thing we can do is find the kind of differences between our original review and the model's output. So we're going to use this Redlines Python package to do this, and we're going to get the diff between the original text of our review and the model output, and then display this. And so here you can see the diff between the original review and the model output and the kind of things that have been corrected. So the prompt that we used was proofread and correct this review, but you can also make kind of more dramatic changes, changes to tone, and that kind of thing. So let's try one more thing. So in this prompt, we're going to ask the model to proofread and correct this same review, but also make it more compelling and ensure that it follows APA style and targets an advanced reader. And we're also going to ask for the output in Markdown format. And so we're using the same text from the original review up here. So let's execute this. And here we have a expanded APA style review of the soft panda. So this is it for the transforming video. Next up we have expanding, where we'll take a shorter prompt and kind of generate a longer, more free-form response from a language model.
Okay. So that'll be all for this video. Take care. Bye-bye.